Today we're looking at the rational roots theorem, which means when you can't factor a polynomial to try and solve it, you can formulate guesses for the answers, for the solutions, for the zeros, for the roots, and this is how you do it. So let's first take a look at an example. And these are the same examples that are on your handout, and then I'll do a couple more. So here, the first step that I'm going to do is try and factor. And if I were to try and factor, I would divide by what? X squared. And that would give me x minus 8. And that just looks like I can only divide by 1. So that would be 11x plus 20. That doesn't work out. Those are the same. So that doesn't, I can't factor. At least I can't factor with the normal methods that I have for factoring. So what can I do? This is how I formulate my guesses. The first thing that I'm going to do is write all the factors of this number, and I'm going to call those p. So these are my p values. What are the factors of 20? Like what times what gives you 20? Well, 1, but we're going to say plus and minus every single time, plus and minus, because we can always do a negative factor as well. Like a negative 1 times a negative 20 will give me 20. So we always do plus and minus. And then, so 1 plus and minus 2, I gotta do plus and minus. Plus and minus 3, no, 4. Plus or minus 5. I'm just writing down the factors. All of these could multiply out by something to get 20. Plus or minus, I guess 10, right? Plus or minus 20. 1 times 20 works. 2 times 10, that works. 4 times 5, yeah. Okay, so those are all the factors of this term. Next, something I'm going to call Q. Those are going to be all the factors of the coefficient here. Well, that coefficient is 1. So really, the only factors are plus or minus 1, which makes this super, super convenient. So, we're not there yet, but our guesses for what could be our solutions, our rational roots. What? Our guesses are going to be p divided by q, and it's all combinations of these. What do you mean all combinations? I mean you would take p and you divide it by this. I mean it's plus or minus anyway, so it doesn't matter too much in this particular case, but in other cases it will matter. So what are my p's and q's here? Well, I can have plus or minus 1 divided by plus or minus 1, so really the sign doesn't change. And I'm actually not going to write the bottom since it is just 1. But it's there, and in your handout you have that. Actually, I will write it because we are dividing these. Plus or minus 4 over 1, plus or minus, and so on. So those are my guesses for my my roots, or my zeros, or my solutions, or my x-intercepts. Those are all the guesses that I could have. I mean, it's not all of them. It's definitely not all of them. There's only 3 solutions for this, but it could be any of those. And so, how do we figure out in a quick way if it is a solution? We can use synthetic division. So after we write all possible combinations of p divided by q, which we did, after writing all of those, then you can test the possible solutions by using synthetic division. So how do we do synthetic division again? First we got to write down the coefficients of our polynomial. 1, negative 8, 11, and 20. Great. And then what am I going to test out? So I'm going to say, let's test the first one, just a positive 1. Let's test x plus 1. That's what I'm going to say there. So if I'm testing x plus 1, I got to put a negative 1 there, right? And then what do we have? I'm just going to do the synthetic division. 1, negative 1, that's negative 9, positive 9, what is that, 18? 9, no, that's 20. And then negative 1, no, negative 20, right? Oh, look at that. If it goes in evenly, like if your synthetic division works, then you've successfully, like you know that negative 1 is going to be one of your answers, which means x plus 1 is a factor. We did this before, so it'll help us if we write it in a certain way. So remember, this is my constant term, this is my x term, this is my x squared term. So really, after I divide by x plus 1, I end up with a polynomial that looks like this. X squared, right? 1x squared minus 9x, right? Plus 20. And that equals 0. If you were to multiply this out, you would actually get back to this. So it's kind of a way that we just factored without actually having to factor. We just guessed and then wrote out the factors. And then the next step is to try and use x factoring for this. Try and use the big X. So that'll be what, 20, negative 9, be negative 5, and negative 4. And I can use the shortcut for this, so this will work out. So I have x plus 1 times x minus 5 times x minus 4, and that equals 0. So I can set each piece equal to 0 and solve. That's just going to be really easy. Negative 1, x equals 5, x equals 4. So we got all those 3 answers. And look, that's what I was saying with the synthetic division. Well, we got it. Oh, look at that. So what the heck did I just do? What was all of this? To find all real solutions, we're trying to figure out guesses. That's the p's divided by q's. And then it just happened to be, like, first try, I got a guess that works. If you get a 0 remainder, this is probably something good to write down. If you get a 0 remainder, of course, what you checked was indeed a factor, and you can write it out in factored form with the new polynomial. So make sure you understand what that means. So we checked x plus 1. So I'm going to write x plus 1, since I got a remainder of 0. I'm going to write x plus 1 times my new polynomial, and that's going to equal 0. This represents the same thing as this, and then I just use my normal factoring methods to figure out the rest. And then I can set each piece equal to 0 and solve. Alright, I'll do another example in a minute.